All right, lesson 9.1, well, all of chapter 9 is about sequences and series. And we'll just focus on sequences to start here. Sequence is just when you got a group of numbers and they follow some certain pattern. There's going to be two types of sequences, or I should say two types of formulas that we're going to work with today. One will be called explicit and the other one will be recursive. Now, an explicit formula is just like what we've been doing all year, where you've got some x's, an x or multiple x's. You plug in for those x, for that x, or for those x's, and you get a y. That's all explicit is. You're going to plug in for something and get a result. Well, we don't use x's and y's on here. What we use when we're dealing with sequences is n and a sub n. So n is like our x, that's our input, or we'll call it an input. And a sub n is the y we get. Down here, example 1, I want to find the first 5 terms of this sequence. So I'm giving you a formula, and I want to find 5 terms. A sub n means the nth term. And so when you see a sub n, that just means any term in our pattern. Therefore, a sub 1 means the first term. And if I want to find the first term, I simply plug in a 1 for n. And follow the order of operations. I get 1 squared 1, 3 times 1 is 3, minus 4, negative 1. Notice that n is the little number down here, the subscript. So I want to find a sub 2, that's the second term. I plug in 2 for n. My n. 2 squared is 4, 3 times 4 is 12, 12 minus 4 is 8. And we just need to go all the way up to a sub 5. I want to pause it this time so you can get it yourself. See if you got it. And I'll just continue now. 3 squared 9 times 3 27 minus 4 23. 3 times, plug in 4. 4 squared 16. 3 times 16 is 48. Minus 4 is 44. Plug in 5. Minus 5 squared 25. 3 times 25 is 75. Minus 4 is 71. So what I've done is I've found 5 terms in a pattern. And that pattern would be represented by this formula that I started with. And that's an explicit because you plug in for an n and you get a result and it tells you the number that's in that position. Recursive is different. In order to run with a recursive formula, you need to know a number and then you build off that number. If I don't give you a number, you can't do anything recursively. So recursive is like you're going backwards to come up with an answer. So in order to understand recursive, you need to understand that a sub n is the nth term. We've already mentioned that. So that's any term in a list. If a sub n is some term in a list, then what's a sub n minus 1? Well, a sub n minus 1 is simply the number to the left of a sub n, or the nth term. How about a sub n minus 2? Well, that's simply the number 2 to the left of a sub n. Last one I got here is a sub n plus 1. Well, that's the number that's 1 to the right of a sub n. So just to clarify here, let me put down a list of numbers here, some kind of pattern. I'll make a real crazy one here. 2, 3, 4, 5, 6, 7, 8. If I asked you what a sub 4 was, hopefully you'd say a sub 4 is 5, because 5 is the 4th number in. 1, 2, 3, 4. If I asked you what a sub 7 was, hopefully you wouldn't say, oh, there's a 7 there. No, hopefully you'd go, what's the 7th term? Well, it's 1, 2, 3, 4, 5, 6, 7. It's actually 8. Okay? let's say that I want this to be just a sub n. I mean, it's really a sub 4 because it's the fourth term. Let's say 5 is a sub n. Then 6 is a sub n plus 1. 7 is a sub n plus 2. And 8 is a sub n plus 3. Going the other way, you'd have a sub n minus 1, a sub n minus 2, a sub n minus 3. So that's what these a sub n with that extra number mean. It just means you're going to the right or to the left. So here's a recursive example, example 2. Basically this is saying to get some number, to get some a sub n, I simply need to take 2 and multiply it by the one to the left. And then I add 3. Well, if I'm going to come up with a number, I need to know the one to the left. So the only way to do this is if I start you off with one of the numbers. So I'm going to make a list of 5, and I've already given you 1. Now I'm going to try to find a 2. To find a 2, I need to take 2 times. So to find this one right here, I need to take 2 times whatever's to the left, which is 4. Or I could have said before, which you see 4 before there. And add 3. Order of operations, that gives me 11. To get the third number, so again, this is A1, this is A2, this is A3. To get this third number right here, I take the 2. The 2 is always in my formula up here. I'm always going to have a plus 3. But I'm going to take 2 times whatever's to the left, which is 11. 2 times 11 is 22. Plus 3 is 25. To get a sub 4, I always have that 2 times. I have that plus 3. I'm going to take 2 times whatever's to the left of A4, which is 25. 50 plus 3 is 53. And last one, need to get a sub 5. Always going to have the 2 times. Always going to have the plus 3. 2 times, 1 to the left. What's to the left here? 53. Gives me 106 plus 3, 109. There's the first 5 terms in that sequence. Example 3, I've got another recursive one here, only this one looks a little different because you actually have 2 terms that they're talking about in relation to a sub n. So you actually need to know 2 numbers. So here I've told you the first 2 numbers are negative 2 and 7. So we got A1, A2. And we're going to find 3 more. Get rid of that there. Find 1, 2, 3 more. So it says to find some a sub n, we simply take a sub n minus 1, which is just to the left, so 7. And this one's going to actually be a sub 3, so let's change that a sub 3. So we're going to go 7. And then we're going to add that. This means 2 to the left, so we're going to add 2 to the left, which would be negative 2, and that gets me 5. And that's my third term. To find my fourth term, I'm just going to write my pattern again here. To find my fourth term, I take 1 to the left, which is 5. I'll use a different color here. See what's going on. So I get 5. And I added 2 to the left, which is 7. And that gets me 12. Okay, one more. We're going to find a sub 5. Find a sub 5. I take 1 to the left, which is 12, and add a 2 to the left, which is 5. And I get 17. And there are the first 5 numbers in that pattern. The first 2 were given to me, the negative 2 and the 7 were given to me. I just had to find the other 3. Example 4. This one again is recursive because I see I have an a sub n minus 1, but it also has a minus n on it. So I've got a sub n equals a sub n minus 1 minus n. I'm going to find the first 5 terms. When I give you one, it's 12. And I need to start finding A2, A3, A4, A5. Well, to find A2, that would be my second number. It says use A sub n minus 1. That's 1 to the left. It's 12. And then I subtract n. Now, I don't know, for some reason, some students have trouble understanding what n is. N is just the number down here in the subscript. So we're going to subtract 2. In this case, 12 minus 2 is 10. Moving on. A sub 3. We're going to take A sub n minus 1, which is 1 to the left, so that's 10. Then we subtract n, which again is this number right here. In this case, it's 3. Gives me 7. Find A sub 4, we take 1 to the left of that, which is 7. Just taking your previous answer. And we subtract. What do we subtract here? Well, we've got a 4 in the subscript. That's our n. Our fourth term, we plug in a 4. So we get 3. And finally, we're going to take our previous answer and subtract 5 in this case, and get negative 2. There's our 5 terms. Okay, last problem. Here we're actually going to write formulas. We're going to write one that's explicit, and then one that's recursive. And once you get the hang of it, recursive is actually easier than explicit. Because recursive, all you have to do is identify what's going on. And I can see up here that I'm adding 3 over and over and over again. So to find some A sub n, I simply look at the term to the left, A sub n minus 1, and I add 3. That's all there is to it. Except for on a test, if you leave this would only be half credit because you got to tell me where to start. There's no way I'm going to know to get 12 for my first term unless you tell me that my first term is 12. And then I can actually get my second term of 15 by going 12 plus 3 is 15, so on and so forth. So it's important to have that key there. You need both of these for recursive. Explicit, I'm not going to have any A sub n minus 1 stuff or anything like going on. I'm just going to have an n over here. And the question is, what do I do to n? So I've got A sub 1. That means plug in 1 for n. Well, what do I got to do to 1 to get a 12? Because the first term is supposed to be 12. Well, looking up there, I see it's a bunch of plus 3's. And what that means is, if I'm adding 3 a bunch of times, I can look at that as, instead of adding 3, multiplying by 3. Like, to go from 12 to 24, I got to add 3 4 times. And rather than going 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, I can just go 3 times 4. So that tells me that I should be doing 3 times something. Well, if I just left it as 3 times n, my first one would be 3 times 1, and that'd give me 3. And that doesn't work because it's supposed to be 12. So then you might think, well, I'm just going to try adding 9, and if you think that, you'd be correct. Because that would give me 12 for the first term, and if I plug something else in, let's say I want to find A4. That means I got to do 3 times 4 plus 9. That'd be 12 plus 9, that'd be 21, and if you look up top here, that's what A4 is. It's right here. That's A sub 4. 1, 2, 3, that's the fourth term. Okay, so this is your explicit rule. And you might think that's kind of tricky, but tomorrow, or in our next lesson, I should say, we'll go over exactly how to come up with the pattern when it's going up or down by the same amount. The hint is, you guys have done it before, it's a linear situation because this 3 right here, it's basically slope. And I can look at these as ordered pairs. What I've got here is I can think of this as an XY chart. My first term is 12, my second term is 15, my third term is 18, fourth is 21. Hopefully you can say, oh, look, it's got a rise of 3 and a run of 1. That means it's linear. Okay, and you can see this is a linear situation. That's like mx plus b. But again, more on that in section 9.2. Thanks for watching. Have a great day.